Okay, let's talk about how to use the diffusion calculator to calculate the average time that it takes for a chemical to travel a certain distance or to diffuse a certain distance. So first thing we need to do is find the diffusion calculator, and I'm going to use the Google search tool for that. Diffusion calculator. And this is the calculator we want, the one from the physiologyweb.com. So the physiology web calculator has some information on the equation used to make the calculation. It has a table of some chemicals and their atomic weights and the diffusion coefficient. We'll come back to what that is in a minute. And then, of course, here's the calculator itself with the three variables in the equation. And if you enter 2 and calculate, you will get the third. Okay, so let's look at this equation. T is the time that T is the average time that it takes for a population or a system of particles to diffuse a certain distance. And that distance is x, right? And this time is inversely proportional to the coefficient. So the bigger the diffusion coefficient, the less time that it makes. So the diffusion coefficient itself is here in this rightmost column, and it's a function of the size of the particle. So the smaller the chemical, the bigger the diffusion coefficient. Really big molecules like hemoglobin and DNA especially have much smaller diffusion coefficients, right? So here we're on the order of magnitude of 10 to the negative fifth, 10 times smaller, 100 times smaller, 1,000 times smaller for DNA. So here's our equation, and here's our calculator. So let's compute the diffusion time, that is the average time for an infinite number of molecules. All right, let's compute the diffusion time for oxygen to diffuse from the air in the lung alveolus to the blood in an alveolar capillary. And that structure between those 2 points, the air in the alveolus and the blood in the alveolar capillary, it's called the respiratory membrane, and it's about a half micron in distance. So our distance is a half a micron. So we want to put 0.5 there for x, and we want to make sure we choose the correct unit. The default is centimeters. It's not centimeters, it's microns, micrometer, right? And we need the diffusion coefficient for oxygen. So here's oxygen. Here's the diffusion coefficient, 2.1 times 10 to the negative fifth. This is scientific notation. We can't use that in the calculator. We need to use what's called the E notation. All right. So we want to put 2.1 E to the exponent there, negative fifth. All right. Before we hit the calculate button, we want to put the units of time into something reasonable. So I'm just going to leave it in seconds here, and we'll come back to what that is. So let's calculate that, and we have 0.00006 seconds. That's something it's hard for me to wrap my brain around what that number is. We want this number to be something around 1 or 10. So we want the units here so that this is a manageable number to understand. So I'm going to just click over to microseconds and put calculate. 59 microseconds is the answer. All right. Again, if we put nanoseconds, we have a big number. I have to start mentally inserting commas in there to be able to read the number, and I don't want to do that. If we have a unit like hour, I don't even get a result. Okay, so we want to use a unit that makes sense for the purpose. So here's a common error that occurs with the physiology calculator, and that is when you get a number that's really, really, really small, a result for time that's really, really small, and it can't display it, then it can't fix itself. So you have to just redo the whole thing. So clear all and redo it. 2.1 X is a half micron. We want it in microseconds. Calculate. Right? So our answer is 59.5 microseconds is the average time of diffusion for the system of particles.